Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 6 to 10 of the Algebra 2 Common Core New York Regents exam for August 2016. Alright, let's take a look at problem number 6. It reads, Sally's High School is planning their spring musical. The revenue R generated can be determined by the function R of t equals negative 33 t squared plus 360 t, where t represents the price of a ticket. The production cost C of the musical, represented by the function C of t, equals 700 plus 5t. Question: what is the highest ticket price to the nearest dollar they can charge in order not to lose money on the event? Alright, in this situation, there are two things going on, okay? There is money going out of your wallet, money spent in producing the show, and there's money coming in, the revenue that they generate from charging students the ticket fee for watching the show. The goal here is to charge sufficiently high price per ticket in order to cover all the costs spent involved in producing the show. Okay? Now let's take a look at the following setup. We have money. Let's do money coming in. So money coming in is from what? Money in is your revenue from ticket sales. Okay? That's the money coming in. And you have money going out. Money going out is the cost to produce. Okay? All the expenses involved in setting up the show, that's the money out. Now this is the goal. The goal is to make sure that the ticket price is sufficiently high in order for the cost of production to be fully covered. So let's take a look at the following scenarios. So if the revenue is less than the cost, what happens? The money that they charge from selling tickets, if it's not sufficient, if it's less than the money they spent making the show, then in this case they suffer a loss. Alright? What happens if the revenue is equal to the cost? In this case, they break even. Okay, this is the minimum requirement. So this is where they want to be at. Either it's equal to or greater than. Okay, so no loss. We have a break even. Alright, remember the problem says how much can they charge in order not to lose money. Okay, in order to not lose money, we're talking about no loss here. Now what happens when the revenue is greater than the cost? This is beautiful because in this case they actually have a profit. But that's not the goal. The goal here is to make sure that they at least cover the cost involved in producing the show. Okay, so in order to guarantee that there is no loss, what we're going to do with taking a look at this scenario right here, we're going to solve the equation for t. What equation? We're going to solve the equation R of t, the revenue, equals the cost. Okay, if we can solve this equation for t, then we'll know the highest ticket price that they can charge in order not to lose money. Alright? So what we're going to do is just simply substitute the value of each function in this equation. R of t is negative 33 t squared plus 360 t, and C of t is 700 plus 5t. Now if you take a look at this equation, you notice that we have a quadratic equation because the highest degree is 2. So how do we solve quadratics? We want to first put it in standard form. Okay, what is the standard form? ax squared plus bx plus c equals 0 form. We set the equation equal to 0 with degrees in descending order of magnitude. Okay, so to make this easy to do, we'll just simply subtract 5t from both sides and subtract 700 from both sides in order for it to be equal to 0. Let me switch this around here. We have 5t. I can subtract it from 360, 700, just put it over here. Okay, now when we combine these two, we're going to end up with the equation in standard form, which is, I'm going to write the highest degree first, negative 33t squared. Now 360 minus 5 is 355 plus 355t minus 700 equals 0. So there goes our quadratic equation. Okay, now what we're going to do is we're going to solve it. There are different ways you can solve a quadratic equation. Because of the nature of the numbers here, I'm just going to go straight to the quadratic formula. Okay, what on earth is the quadratic formula? Let's refresh our memories on that. Quadratic formula, t equals, it's normally x, but the independent variable here is t, so we have t equals negative b plus or minus the square root of b squared minus 4ac, the entire thing, divided by 2a, okay? Alright, so all we need is a, b, and c. We substitute it into this equation and we solve for t, okay? So a is the coefficient of the second degree term, so a is equal to negative 33. B is 355, the coefficient of t. B is 355, and we have c is negative 700. Okay, so let's substitute. Now, whenever you're making substitutions into the quadratic formula and one or more terms are negative, you want to proceed with caution, okay? What will enable you to avoid making mistakes? Make use of parentheses whenever you're substituting that negative term. So we have negative b, negative 355, plus or minus the square root of b squared, 355 squared, minus 4ac, so 4a. Notice how I put it in parentheses, c. So putting negative numbers in the parentheses allows you to avoid making errors associated with signs, okay? And then over 2a, we have 2 and a is negative 3. So just simply plug this into your calculator. You can plug in the radical part and then take the square root. You end up with negative 355 plus or minus 183.3712, and that will be divided by 2a. A is negative 33. Okay, so divided by 2a, and then you have negative 66. Okay, now let's go ahead and simplify further. Now you have plus or minus. This is where you split your equation into two parts. Okay, so that sign basically results in the separation. We have the negative part, negative 355 minus 183.3712. That divided by 2a, which is already expanded to negative 66. And then we have the positive part, which is, so t is either this or t is that value right there, which is negative 355. Instead of a minus, now we have a plus. Okay, 183.3712, and you divide it by negative 66. If you input this into your calculator, you get t equals 8.16 and t equals 2.6. Okay, so we're looking for the highest of the two in order not to lose money. So t is going to be equal to, We're rounding it to the nearest dollar or nearest whole number, so t is equal to 8. So t equals 8 is the highest price. Highest price to charge in order not to lose money. Okay? Alright, let's take a look at problem 7. It reads, the set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phones each month. Okay, so we have the age group right here, and then the text messages per month. If a person from this survey is selected at random, what is the probability that the person texts over 50 messages per month, given that the person is between the ages of 23 and 60? So, just a quick tip. Whenever you're working with probability problems and you see the word given, that automatically tells you that you're dealing with a conditional probability type problem. Okay? So given implies that we're dealing with conditional probability. Okay? With a given condition. So if you think about conditional probability, there's a formula that is applicable to these type of problems. Okay? So the probability of A given B, so this bar right here means given, probability of A given B is basically the probability of A intersect B, or A and B, divided by the probability of B. Okay? In this particular setup, we have a tabular version. Okay? Whenever you're dealing with tabular version of a conditional probability problem, this is how you approach it. So for a tabular version, the probability of A given B is basically the number in the cells that represent the intersection of A and B divided by the quantity of numbers in just B by itself. Okay? Alright, so let's go ahead and set up the problem. So just to help you with the setup, I'm going to let's determine what A and B are, okay? So A is basically what comes before the given. So we have given right here, so what comes before given? A person texts over 50 messages per month, okay? So A is the event that the person texts over 50 messages per month. So A is going to be over 50 messages. Okay, let's put over 50. And then it says given that the person is between, so that's what B is, what comes after the given that the person is between 23 and 60. So let's call B 23 to 60. Okay? Alright, so we have our A and B. So the formula, we're going to apply the formula here. Probability of A given B is equal to the number in this table of A intersect B, that's over 50 and text 23 to 60 messages, divided by the total number of B. Number of B here just basically represents the number of text messages that people in this age bracket text. Okay? Alright, let's start with number in A intersect B. In the context of this problem, it basically represents the number of people that are what? Over 50 and people that text over 50 text messages and are between the ages of 23 to 60. Okay, people between the ages of 23 to 60 and text 50 text messages, over 50 text messages. So let's go back to the table. So the people that are over 50 fall in this column right here. Alrighty? And then the people that text that are between the ages of 23 to 60 fall in this column right here. Now, do you see the intersection? The intersection is 157. The number of people that are between the ages of 23 to 60 and text over 50 text messages per month. So A intersect B is going to be 157. And then number in B. To get the number of B, all we'll just simply do is add up all the number of text messages in the B row. Okay, so just add this one, add, and add. Okay, and then find out what the sum is. So for number of B, so this is equal to number of B, it's going to be 25 plus 47 plus 157. Okay, just extract the numbers in this row right here. If you add it all up, you have 229. So probability of A given B is going to be number of A intersect B, which is going to be 157 divided by the number in B, which is 229. Alright, so your final answer is option number 1. Alright, let's take a look at question number 8. It says a recursive formula for the sequence 18, 9, 4.5, ... Basically, the sequence continues is... Now, first of all, let's take a look at the question. We're asked for a recursive formula. Okay, what do we know about recursive formulas? I'd like you to recall this fact. Recursive formulas, recursive formulas have an initial term and a recursive equation. Okay, recursive equation. So recursive formulas have two parts. They always have two parts: the initial term and a recursive equation, which is normally dependent on that on a term and its subsequent term. Okay, the term before it, its previous term. Now, just with this fact alone, based on the definition of what a recursive formula is, we can eliminate options from 1 to 4. Okay, take a look at 1. We have an initial term and a formula. Good. 3, we have initial term and a recursive formula equation. Good. 2 and 4 are not recursive formulas. Okay, what are they? These are known as explicit formulas. Okay, so this is not recursive. This is an explicit formula that represents exponential decay. In this case right here, this is not recursive also because it doesn't have the two parts that are required. This is an explicit formula representing exponential growth. Alright, so our answer is either option 1 or 3. So all we have to do is just delve into the sequence and see what parts of the sequence matches one of these options right here. So the first part of the sequence has to do with the first term. Okay, remember recursive formula has the first term, which is a1. So a1 is equal to 18. And both of them have an a1 that's 18 and 18, so that's a check. What's going to distinguish them is the growth rate. This one has a growth, this one grows by repeatedly multiplying by 1/2, and this one grows by repeatedly multiplying by 2. So which one do you think is correct? Let's take a look at it. So from 18 to 18 to 19 to 9, what's the common ratio here? Alright, because it's multiplicative, this is basically a geometric sequence. To get the common ratio, we'll just simply divide a term by the term before it. So a2 divided by a1 will tell us what the common ratio is. Alright, so a2, you could do a2 over a1, which is the same thing as a3 over a2. Doesn't matter. Let's do a2 over a1. a2 is 9 divided by a1, which is 18. The common ratio is 1/2. Okay? So what does this mean? It means that in order to generate subsequent terms of your sequence, you have to constantly multiply by 1/2. 1/2 and 1/2. Okay? So what does that tell us? We can automatically see that the correct formula is option number 1 because it indicates repeatedly multiplying previous terms by 1/2 in order to get the next term. Okay? Remember, when your common ratio is between 0 and 1, it causes the terms of your sequence to shrink. As you can see here, it's shrinking. But when your common ratio is greater than 1, then it causes it to grow. Alright, so that we can clearly see why this is the wrong answer, because these numbers would have been going up by multiples of 2, like you have 18, 36, 72, and on and on. So this is wrong because it failed this part. This one passes both tests, so our answer is option number 1. Alright, let's take a look at question number 9. It says, Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week can reduce the risk of injury. If Kristen runs 8 miles in week 1, which expression can help her find the total number of miles she will have run over the course of her 6-week training program? Okay, so one tip you want to keep in mind concerning growth rate, so let's write this down, tip, is that if you have an increase by r%, okay, all you're going to be seeing is basically the initial amount times 1 plus r% in decimal form, which is r divided by 100. Okay? In this particular case, what kind of increase does Kristen want to see? She wants to see a 10% per week increase. So what's her situation going to be? An increase of 10% basically implies that our r value is going to be equal to 10%. Okay, and 10% in fractional form is 10 over 100. In decimal form is the same thing as 0.1. Okay, now let's go back to this formula right here. If you have an increase of 10% with whatever initial amount, if we substitute this scenario here, it's going to be, so a 10% increase is going to be a times 1 plus 10% in decimal form, which is 0.1, which is a times 1.1. Okay, and it just depends on the number of times that she has the increment done. Okay, so in this case we're looking at 6 weeks, but t represents the number of times. So in her scenario, let's take a look at what we can do here. What happens in week 1? In week 1, we know that the original amount for her A is how many miles is she starting with? She runs 8 miles in week 1, so that's her starting amount. So her A is 8. The rate of increment is 10%, okay, for each week. So if we take a look at what happens at week 1, what happens at week 1? We have she runs 8 miles, okay, and then we have 1.1 raised to the what power in order to get 8. we raise this to the 0th power. Okay? Now, what happens in the second week, week 2? We have the initial amount, which is 8 times 1.1 raised to the first power. What do you think is going to happen in week 3? It's going to be 8 times 1.1. You see the pattern here? Week 1 is 0, which gives you 8. Week 2 is 1. The next one is going to be 2. So let's make a generalization here. What is she going to have to run in n weeks? In n weeks, she's going to be running 8 times 1.1 raised to the nth power. Okay? Actually, n minus 1 is always 1 less than the subscript. So 8 times 1.1 raised to the n minus 1 power. Okay, so we're looking for the total number of miles she runs over the 6-week period. So total number of miles. Now what I'm going to do is write it down in its expanded form. And then we are going to condense it using sigma notation as provided for us in the options, okay? So we have week 1 is 8 times 1.1 to the 0th power. Week 2 is 8 times 1.1 to the first power. Week 3 is 8 times 1.1 to the second power. Week 4 is 8 times 1.1 to the third power. Week 5 is 8 times 1.1 to the fourth power. And then week 6 is 8 times 1.1 to the fifth power. So what you notice is that this is pretty long. Is there a condensed way of writing down the sum? Okay, because what we're trying to do basically is add everything together. Okay, but how can we express it using summation notation? So what we're going to do is we're going to write this as a sum. We're adding from n equals the starting index. We're starting from 1. Okay, we're going from 1 all the way to what? All the way to 6. We are adding 6 discrete terms. So n is what we're going to be using to index our operations. We're going from 1 all the way to 6. That's where you stop. And then we have 8. 8 is unchanged, okay? And then we have the 1 plus the growth rate, which is 10%, so that comes out to 1.1. Now, for each iteration, do you notice what changes? The power. Okay, the power is always 1 less than the index, so we just take the index here, which is n, which is going to be assuming values from 1 to 6, and just take away 1. Okay, so this, what we have right here, is exactly what we have here in a condensed format. Okay, imagine expressing the sum of 200 items. Okay, 200 iterations following this pattern. Think about how long it's going to take you to write it down, but you can just use your sigma notation to condense the entire summation expression into one nice little package. Okay, so let's take a look at the options that we have here. We can clearly see that our answer is option number 1. Alright, let's take a look at question 10. It says, a sine function increasing through the origin can be used to model light waves. Violet light has a wavelength of 400 nanometers. Over which interval is the height of the wavelength decreasing only? So one thing I'd like you to remember is that one wavelength is a complete cycle, okay? It can also be thought of as the period. So one wavelength is one period. So we're looking at the we're looking at a sine wave here, okay? Do you remember what the sine wave looks like? Sine looks something like this. So let's say we have our axis. Sine looks like, that doesn't look good. So like this. Sine looks like an S. So starting from the origin, it goes up to the maximum, down to the center, bam. Okay, that's what the sine wave looks like. See the word S? Sine is like an S. This is one complete period of your sine function. Cosine, on the other hand, does not start from the center like the sine function does. Cosine starts from the maximum. It goes from the maximum, center, minimum, center, max. You can graph it in your calculator just to verify. So this is what a cosine looks like. Cosine is like a cup, okay? Sine is like an S. Now, we are graphing the sine function with a period of 400. So we want to make an S that has a horizontal span of 400 starting from 0. All right, so let's go ahead and sketch that real quick. So so this is just our sine wave right here. The amplitude is not indicated, so let's just say it goes, that's the maximum and that's the minimum, and it's going to be oscillating between the max and the min. One full cycle will be 400 nanometers long. So let's see how we want to divvy this up. So we're going to break it into fourths, okay? So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant for a complete cycle. Sine, remember, is S, starts from the center. Okay, center, max, center, min, back to the center. Okay, so this is 400. This is 400 right here. We're breaking it into fourths, so this is going to be 300. This will be 200. This right here will be 100. And this will be 0. Okay, let's go ahead and draw our sine curve. So concave down to the max, concave down to the center. Oopsie. Let's draw that again. So concave down to the max, and then concave down to the center, concave up to the minimum, and then concave up back to the center. Alright, so there goes your sine curve. The problem asks for where is it decreasing only. So if you take a look at this graph from 0 to 100, what's happening? It's increasing all the way to 100. And then after it hits its maximum, it reverses course and starts to decrease all the way down to 300. And then it hits its minimum, reverses course again, and increases back to the center. That's the typical behavior of a sine function. So on what interval is the function decreasing? Basically, where are you going down from left to right? As you can clearly see, the portion in red from 100 all the way down to 300, right there, the function is decreasing only. Okay, so it's decreasing. Let's write that down. Decreasing only from 100 all the way to 300. So that's your final answer, and we can clearly see that our answer is option number 2. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for the upcoming Algebra 2 Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we'll be more than glad to support you. Do not forget to subscribe to our channel for the remainder of this review series. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day. Goodbye.